Hi everyone, Kalimera. Thank you so much for coming to this session. This is my first time at Devoxx Greece. I'm very excited to be here. In fact, it's my first time in Greece overall. So yes, super happy to be here and super happy to see you all. And in this session today, we'll talk about GraalVM and more specifically the AOT native image part of GraalVM and how you can make your Java applications even more awesome and even more fast. So let's go into it. A little introduction first. So my name is Alina, and this is how you can find me. Oh, what's going on? All good. So this is how you can find me on social media, Twitter, GitHub, wherever, if you want to ask any question or make any comment or follow up. And I work as developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, and that is the R&D part of Oracle, where we're doing a lot of research, creating brand new bleeding edge technologies. GraalVM was such a research project as well. And I love open source and I love communities. That's why I love coming to conferences and getting to talk to people. And I love both programming and natural languages. I'm very open to learning new languages. I can speak like a tiny bit, a couple of words in Greek, and I'm very open to learning more if you can teach me during the break. And the last random fact as an intro is I'm both a cat and dog person. I own a cat, but if you prefer dogs, don't come after me. I love dogs as well, and I hope to have a dog one day as well. And this is how you can find me if you want to ask questions, follow up, etc. So let's talk about GraalVM. And for first, I want to ask you, how many of you have tried building something with GraalVM already? Okay, I would say maybe half of the people. I'm very happy to see that. Okay, so just to quickly sync up on what is GraalVM and why would you care. And GraalVM is a high-performance JDK with this native image compilation part to it. So one important thing to remember is that GraalVM is built on top of JDK, and it just adds to the JDK. It does not take anything away. So in every situation where you can use a JDK, you can just also use GraalVM as your Java distribution. And when it comes to Java, GraalVM gives you two important ways to run Java. So you can run Java applications on GraalVM as you would with OpenJDK, Oracle JDK, etc., by doing your Java command and passing your application to it. Or, and that second part is new and only specific to GraalVM, you can build a native image version of your app that will be a native executable, fully compiled, fully optimized ahead of time. And the reason to do so is because then it can run without a JVM. You can deploy it on the machine that doesn't have any JVM on it, and it will be fully functional, fully working on its own, and also very fast. Now, this is not the complete info. There is one more secret way to run Java on GraalVM, but for the sake of this presentation, let's assume there are two main ways. And I like showing this slide because A, I just like this beautiful timeline we created, but also I like showing this history that we have made with GraalVM so far. So I mentioned the GraalVM is being developed by Oracle Labs. It has been a research project for over a decade at Labs, and then we went GA in 2019. And what's cool here is you can see that some people have been using GraalVM and specifically native image in production from as long ago as 2020. And I think it's pretty cool because it might seem that GraalVM is this big, new, revolutionary project, and it is. But also there have been people who have been happily using it for 5 years now, and I think it's pretty cool. So if you're looking for some kind of guarantees or like references that it's stable enough and can be used in production, there have been people who have been doing that for 5 years now. And let's talk about specifically this native image part of GraalVM and how it works, and how is it even possible to take something as dynamic as a Java application and compile it ahead of time. So when you run your native image command and give it your application, and as an input, it takes bytecode. So you need to give it your class file or your jar, and then it will produce a native executable version of it. And the way this happens is that all of this is being done ahead of time at the build step, so when you build your application. And this is probably the biggest difference of native image versus the JVM, is that the build step becomes very important because all that work that the JVM normally does at runtime, native image does at build time. So when you run the native image command, what it will do, it will look at your entire application, and it will try to understand everything your application does. So it will start with the main entry point, and then from there, it will try to find all the reachable code. So all the code that is essential to what your application is doing, to only include that code in that native executable that you will get in the end and eliminate everything else. So this applies to your code, the code you actually wrote, but also all of your dependencies and even the JDK classes it's using. So we will only include the code you're actively using, and the code that is like not necessary for your app, basically, it will eliminate so that in the end you have this small, compact native executable. And this kind of reachability analysis is one part of the story. Another big step there is heap snapshotting. So as we are doing this, we are also looking at your heap, and we are taking a snapshot. So that when you have native executable, you can start with that snapshot much faster because you don't need to allocate objects anymore. And it's important to keep in mind that this is happening under closed world assumption because we are ahead of time. The runtime hasn't happened yet, right? So this is happening under closed world assumption. Everything there is to know about your app needs to be made known at build time, and we will get back to this later. So in the end, you have a native executable version of your app. Doesn't need a JVM, but also it becomes platform specific, so you need to build for Linux, macOS, Windows specifically. And what could be the reasons? So to go with this and to be using native image. So if you have heard ever anything about GraalVM, you might have heard about fast startups, so how much faster applications are with GraalVM, and that is certainly true. So because we compiled everything ahead of time and optimized your application at build time, we don't need to do any of that at runtime anymore. So when you run your application on a JVM, especially a larger app, you can notice that sometimes a larger app can take maybe several seconds to start. And that is because the JVM is quite busy the very first time you start it as a cold start. So it needs to load classes, it needs to analyze them, compile, profile, and then you can run with a fully optimized code. So native image offers you a trade-off where you move all that work to build time, and you do it once rather than doing it every single time when you start your application. This way you can start much faster, but I would argue that maybe not for all applications this is very important. This is more important for microservices, serverless, etc., for cloud deployments where you spend time using resources and that ends up in your cloud bill. But if you have a more long-running application, so maybe you deploy it once and then it runs for weeks, days, etc., maybe you don't care that much about startup time. And that is when low resources usage comes to play. So again, if you're deploying to the cloud, or maybe if you're doing your own infrastructure, if you can reduce that memory usage, that means you will use your resources way more effectively. And that is another benefit that native image gives you, because we don't need to keep around memory for the JVM, the compiler data structures, etc. So on average, you can expect, I would say, at least 3x less memory usage on native image versus the JVM. And it also has a very predictable performance. So again, the JVM, it warms up over time, but with native image, you have very stable performance from the very beginning and as long as you run your app. It is also more secure, so it adds additional security layer on top of the JVM, and we will get back to that in a second. And also with native image, you can produce much smaller image sizes. For example, if you want to have smaller containers so that you can deploy them faster, scale them faster, that is something that native image can do for you as well. And luckily, in 2024, we also have a lot of support from many libraries, cloud vendors, etc. So it's very easy to build applications with GraalVM now that we have all this support. With all that being said and done, let's look at one such app. I want to show you how you can build such application yourself. So for that, let me run a Spring app that I have over here. Let me just expand this. OK, so this is my native Spring Boot app. And the way this came to be, I just went to start Spring.io, and I created my project, and I added web and native image as dependencies, and that is basically it. So this is my main Spring app. And I also have one controller, so we can see something fun and have something to look at. So let's see what we can do with this app. For that, let me first check my Java version. OK, we are running on GraalVM version 22. Anyone here on Java 22 yet? OK, not yet, but maybe again, maybe after this talk, you will get to change your mind. So let's see if we can run it. Maven Spring Boot run. OK, so this started on the JVM. As we remember, GraalVM is also a JDK/JVM. It can run your apps as you would normally on any other kind of JVM. And we see that our application started in I would say, 0.3 seconds. And let's see what it does. I have a lot of stuff open. Let's just get a new tab. Localhost 8080, hello. OK, seems like I need to remap my ports. 1 sec. So ports, let's drop this. Let's add this again. Let's see if it helped. Yeah, we got our message. But you know, fairly trivial, nothing complicated about that. Let's see what else we can do with this app. Let's close this, and then to compile this to native, I will do the following. So Maven p native, and for Spring Boot, this will be native compile. And it will start a native image compilation process. Now, this command that we will get any second now will look rather scary, this one. But that's only because there is a lot of stuff on the class path, and likely that completion is hidden from me. For me, the command that I run is just Maven p native compile. And it started on the JVM, it packaged my application, and this part over here is when the actual native image build starts. And for me, this paragraph over here is the most interesting one because it shows me the most high-level parameters of my app and my virtual machine. So it tells me that I'm running on Java 22, as we've seen before. It shows me that I'm not using PGO, which is one specific optimization in GraalVM. It shows me some info about my machine, GCC, etc. And it shows me how many resources it found on my machine. Now, a native image build contains about 8 steps. And for each of the steps, we are showing you how much time is spent in that step and how much memory we are using in each of those steps. Now, if you have been using GraalVM a long time ago, maybe, I don't know, 4 or 5 years ago, you might have remembered that back then we used to take a bit more memory than now. But we understand that this is an important developer experience metric, so we are trying to always reduce the time it takes to build an app and also the memory usage of the app. And here, if you pay attention, I mean, it's not the biggest app in the world, but still, if you pay attention, you would notice that each of those steps more or less stays within 2 gigs. So even if you have a very small machine with, let's say, only 2 gigs of free memory available, you can do native image builds there. And the reason why this is impressive is because, you know, you see my app, it's not very big, but it is a Spring Boot app with the dependencies. So if you look at what native image has found in my app, you will see that it has found about 17K reachable types, 25K reachable fields, and a lot of methods. So even for a smaller app, if that's a Java, Spring Boot app, there's a lot of stuff going on, and native image needs to understand all of that, analyze, and compile it. So a lot of work to be done, but we can do it with about 2 gigs of memory, and as you've seen, in 45 seconds, which I think is pretty cool for native compilation. But let's run our app, and let's see what it does in the native mode. So target, and the app name is demo. So let's start it. You remember before it started in 1.3 seconds, now it's down to 47 milliseconds. And if we go here, localhost 8080, it also returns our message. So this is how you would build such a native Spring application. Now, this one was, let's say, fairly trivial, but this is the way you start with such apps. So how do you do something more complex? Let's say I want to keep building my app. I want to add more dependencies. Maybe I want to use database. Maybe I want to use some cool AI stuff. So how do I make all that work with GraalVM, whether that's possible or not, and how do I go about it? So if I want to use some dependencies, a good way to go would be checking out this page that we maintain on our website that is called Ready for Native Image. And if you have an existing app that you know you will be using those dependencies, or maybe you want to start a new project and you want to quickly evaluate whether or not that will work smoothly with GraalVM, this is a good starting page because this very long list of libraries and frameworks tells us what is being constantly testing and integrating with GraalVM and what is being proven to work out of the box smoothly with GraalVM. So if I know that I have an app and it's using those dependencies, I know that I'm definitely good. Now, if my dependencies are not on this list, they might still work. It just hasn't been reported to us that they are working because this is a community-maintained list. But this is, let's say, a bare minimum list that definitely works. And then there are more things in the world that might work, but this is a good first step to check your dependencies to see if they are compatible with GraalVM. Now, let's talk about dependencies more, and I want to stop here because this is a question that I get a lot at conferences. So let's say I have a dependency, maybe it is on that page, maybe it's not. So overall, what are the approaches of libraries to working with GraalVM and native image specifically? And the reason why this is a separate question is because I told you that native image builds your application under closed world assumption. So everything there is to know about your app needs to be known at build time. And this means that some of Java's more dynamic features, the ones that happen at runtime, are a bit more challenging to this programming paradigm because the runtime hasn't happened yet. And all those dynamic things that happen at runtime, there needs to be a way to inform native image that, hey, this will be happening at runtime. You are still building your app. You haven't seen that yet, but this is something I want to do when my application runs. So things like reflection, serialization, proxy, resources might or might not need configuration coming from you or library or framework. In fact, how many of you have heard that GraalVM does not support reflection? Okay, still a lot of people, still a lot of work for me to do to destroy that myth. So GraalVM does work with reflection, but there are things to note. So one is that some basic reflection calls, some that are maybe more predictable, more reasonable, more trivial, native image will figure out of the box as you're building your app. So there is reflection detection mechanism, and then things that are more common, more predictable, native image will figure out of the box. You will not even notice that. Now, if there is reflection happening in, let's say, your library, or maybe you are doing reflection yourself, you're writing some custom code, you need to be able to tell native image that, hey, this thing, I would need to do reflection over here, so please make it visible and please pick it up as you are building my application. And the way this works is that there need to be configuration files in the format of JSON that native image can look at, figure out, and pick up that config and build an app with that reflection point in mind. So the way this works is that native image needs those config files, and here are the ways where they can be coming from, starting with, let's say, optimal versions or optimized way to do those things, and going back to more custom, more manual input from you. So one is libraries can be written in a way that is native image friendly from the beginning, and we see more and more such libraries every day, thank God. So it could be that there is no need for configuration at all, because it's all just written in a way that native image can understand. Now, if that is not the case, and there is a need in configuration, there are multiple ways how this config can happen. I like this example from H2. So if you go to the H2 library source code, I used to show this in the past, how I cannot make H2 work, and then I can make it work by providing config. But now I don't even need to do it anymore, because if you look at the H2 source code, you can see that there is config needed for native image in the actual source code. And by compiling a library that has such config provided, it will just work out of the box, no help needed from you as a user. So this is pretty cool, and we see more libraries adding this. Now, it can be the case that a library doesn't yet support GraalVM or doesn't have a way to integrate this configuration. And it seems like it should be possible to have some kind of central repo where you can contribute and then share and reuse and pull this config from. And indeed, there is such place. So we created this repo on GitHub where users, maintainers, library authors can contribute config for popular libraries. And then if you're using our Maven and Gradle plugins, you can just automatically pull config from this place. You don't even need to know about it. So again, if I look at any random native part over here, I will see that there is a minimal config that is needed for my library to work. Okay, what are some other ways? If you are using one of the frameworks that works with GraalVM, such as that is Spring Boot, Micronaut, Halidon, Quarkus, usually they give you some kind of API and annotation on the framework level. So you can, let's say, annotate an element and say, I want this to be accessible through reflection for GraalVM, and then with that annotation, the framework will generate that config for you. And also, we have a tracing agent that you can run your application on the JVM with, and it will look at what your application does and will produce this configuration for you. So this is kind of complicated. I don't want to stop at this more, but I just want to emphasize here that there are many ways how libraries can work with GraalVM and many ways how this configuration can happen if there is a need for configuration. And then those three first bullets are preferable ways, like that don't need any input from you at all. And this is the happy path, and I hope that it will always stay in those three bullets where you don't need to do anything at all. And then for things that you roll yourself, so if you have some custom code, some custom internal libraries, etc., there are more ways to make things work. But as I said, I hope that most cases, and that's indeed the true for known libraries, you will just stay within those first three bullets and you don't need to do any manual config. But this is just for your own information in case you ever need it. Now, when it comes to testing, we also get this question, so how do I test my application on GraalVM? How does that testing work in the native world? Is there any support from framework, libraries, etc.? And indeed, there is. So I mentioned that we have Maven and Gradle plugins coming from the GraalVM team, and also there is support on the framework level. So for JUnit, there is this module in native build tools, Maven Gradle plugins, where you can work with JUnit tests in the native image mode, and you can even specifically enable or disable testing some things in the native image mode. And then on the framework level, you have more advanced testing capabilities. For example, if you want to do integration testing, let's say you want to test against your database, usually frameworks offer something based on test containers, so you can do integration testing with those lightweight test containers. And that's called in Micronaut test resources, or in Quark with dev services, and also works very well with GraalVM and native image. So for testing, look at what your framework offers, but our general recommendation is that you keep developing your application on the JVM, and you keep testing your application on the JVM, and you don't need to recompile to native very often. You can do it as a part of your CI/CD system, or you can do it maybe once a day, or you can do it close to deployment. But it's not needed to recompile the application to native all the time, because usually things just work, and it will be just wasting your time and resources. Things just work, so keep developing your application on the JVM, and then you can test in native in your CI/CD or closer to deployment. Okay, and let's talk about performance, because I work on a compiler, so obviously I care about performance a lot. And for that, I want to ask you, so if you're comparing JIT code, so a code that is a JIT compiler is compiling and executing, and ahead of time compiled code, which will be faster? So do you think AOT compiled code can be faster than JIT? Okay, there are a few optimists in the room, but not too many, and I understand why, because we come from the JVM ecosystem, and we know that JVM is amazing for peak startup, and it's very hard to beat JVM on its own game, because JVM is executing your code dynamically, it's collecting profiling information, and it always sees what is happening in your app, which parts of the app are more hot than others, and where it makes sense or doesn't make sense to invest compilation efforts. But we have this big ambitious goal that we can make AOT compiled applications as fast as the ones running on the JVM, or even faster. And as an example here, we did measurements measuring the Spring Pet Cleaning application running on GraalVM native image, that is the orange bar, versus running on C2, and C2 is the standard default JIT compiler in the JDK, so OpenJDK, Oracle JDK, etc. And you can see that native image is on par and even slightly above the JVM in terms of peak performance. Now, obviously, this is just one app, and every application is different and has different goals, different dependencies, different code, but something like this is possible. And it's kind of hard to imagine why and how AOT code can be faster than JIT, because, again, JIT is a dynamic system, right? But something that we are missing here is that one AOT compilation is happening under closed world assumption. And this means that we can apply more aggressive optimizations, because we know that there will be no surprises for us at runtime. So as I said, everything there is to know about your app needs to be known at build time. So this means we can be very aggressive in the way we optimize code, because we know that there are no new surprises. We can optimize for those cases that we'll see, and nothing new will happen at runtime. So we can be more aggressive. And also AOT can dedicate more time and resources to the compilation process, because JVM, in a way, competes with your app for the performance and resources, because it compiles your app as you go. But then AOT, we are compiling your application ahead of time, so we can dedicate time and memory in CPU into optimizing it even better, because we have such a luxury of those time and resources being available to us. So this is peak throughput. And I mean, this chart is a bit complex, so I know it takes a couple of seconds to parse, but stay with me. So what is happening here is we are measuring operations per gigabyte per second, and some people call this throughput density. So how much throughput you can get for the amount of resources and the time that it's available to you. So basically efficiency of how you are using your resources to get throughput out of it. And then we are mapping this against XMX. So how much memory you give in your app to see if you're increasing your memory, how does that affect the efficiency of how you are using your resources. And there are two observations here. So one is we see that native image is consistently above C2. So it doesn't matter how much memory you give your app, native image will always utilize resources better, because it doesn't need to compile your app anymore, but it does give you good peak throughput. And one more observation here is that you can see that there is this kind of sweet spot in around 512 megs, maybe to 1 gig. And it seems like there, the throughput that you can get per given amount of resources is almost twice as big in native image versus C2. So if you have an application that is maybe, I would say, smaller to mid-size, you can expect around 2x better throughput density per amount of resources that you're giving versus C2. And I will not stop here, but even if you care about things like latency, maybe you have some very strict CLA agreement with your customer, user, etc., even latency can get quite good with native image as well. Okay, so let's say maybe you want to try building something by yourself, how you can go and build your application, and what are some development practices and tips and tricks that I can recommend to you. One thing when it comes to packaging, if you want to have very small container sizes, native image is very good for that. And here we're comparing a lot of different kind of packaging options that you can have. The blue ones, that is still the JVM, and then the orange ones, that is native image. And you can see how you can go to 20x smaller comparing to the biggest JDK setup. So from 400 max to just 18. And then with native image, you can build also fully static native images. So completely statically linked, and then you can build those and deploy those on very minimal Docker images, and they will be fully functional and just fully self-contained. So if container image is something you care about, take a look at native image and specifically at static native images option. And then again, when it comes to CI/CD systems, I did mention that native image produces native executables that are specific to a platform. So to operating system and also the architecture, because we need some JDK-specific classes for each platform. So unfortunately, cross-platform compilation, being able to compile, let's say, on my Mac machine for a Linux machine, this doesn't work out of the box. But you can use Docker images, or you can use something like GitHub Actions, and there you can just produce your builds for whatever platform you might need. And that's a very good way to do so. And we also have our own GitHub Action that you can just use and pull our latest images. In fact, maybe I can super quickly show you how I have this set up for my demo on GitHub. So this is my native Spring Boot app that we have seen before. And those are my GitHub Actions. And every time I'm committing a new change to the repo, it's rebuilding. And as the result of that, I have set up builds for Ubuntu and for macOS. So let's say I want to give this to my users, customers, etc. I feel like this is a fairly easy way to produce builds for whatever platform you might need. And also, I believe GitHub increased the capacity of those runners in the past couple of years. So now even slightly larger apps, I don't know, GitHub, Spring Patch Cleaning for sure. You can build those on GitHub Actions. There is enough resources, enough memory. And yeah, there is no problem at all to build those on GitHub Actions. So this is a very good answer to having cross-platform builds available with GraalVM. Okay, and I want to say a few words about security because this is a less known fact about native image and less known benefit of native image. So you often hear this, startup, packaging size, but maybe you're less interested in that, but you are interested in security as we all should be. And there is additional security layer that native image adds on top of the JVM. So one thing I mentioned that native image eliminates all the code that you are not using. So it's looking at what your application is doing, and it's very aggressively eliminating everything else. And this way, we are just simply reducing the attack surface because there is less code in your app. There is less to attack, and it's also just a native executable in the end. So attacking it's a bit more complicated than maybe attacking a JVM application. Now, things like reflection and serialization, they require a specific allow list in the form of those config JSON files that I mentioned. And this can be seen as a limitation, but also it's just a different, I would say, paradigm choice where you have more control and more awareness of your application. So none of this serialization, reflection, etc., can happen without you knowing and allowing it, or maybe your library and framework allowing it. So this way, you are more aware and more in control over what is happening in your app. We also have support for SBOM, so you can see what exactly is in your final produced native executable. And the last but not least, there is no longer a JVM JIT compiler at runtime. And there are some attacks that attack the JIT compiler specifically. So those are just not possible with native image because there is no JIT compiler in the end. It's all ahead of time compiled machine code. Okay, and if you want to migrate to GraalVM, those are my recommendations for you. If you want to maybe like take one photo from this presentation, that will be the slide that I would recommend to you. So if you want to migrate an existing application, the number one thing I would do is I would evaluate the framework that you are using and see if I can migrate to the version of the framework that is friendly towards GraalVM. For example, Spring Boot introduced support for GraalVM in, I think, Spring Boot 3.0. And that will be the easiest way to migrate your application to GraalVM. Now, if for some reason this is not possible, or maybe you're not using any framework, or if you're using some custom framework, what I would do, I would add our native build tools. That is the Maven and Gradle plugin coming from the GraalVM team. And this will help you build your applications, test your applications, pull configuration for known libraries. This is a good first step. Now, for building applications, build and test on the JVM as you normally would, and then compile to native in your CI/CD or closer to deployment, or maybe when you're introducing a new dependency and you want to make sure things just work, that is when you want to compile to native. And one small tip, but I like using this -OB flag. So this will speed up your build as you're developing your application. It will enable this quick build mode. It will not be, 2 times faster, but will be maybe 20, 30% faster. So if you just want to have quick feedback for your app, if it still builds, if it's still working correctly, this -OB flag will give you a faster build. And then for running faster, for better peak performance, there is a number of things you can do. One is called PGO, and that is Profile Guide Optimizations. So the way this works is that JVM, the way it compiles your application and optimizes it, is that it collects the profiles of your app at runtime. So it looks at your app, and it records which parts of the code, which loops, etc., are more hot, and where it makes sense to invest compilation efforts. With native image, you can do a similar thing where you would build an instrumented version of your application, collect profiles, and then feed those profiles back into native image at build time. And this way, you're kind of bridging that gap between runtime and build time. So you still have those profiles available from runtime, but you're building your application ahead of time. And this way, you can have performance that is compatible to the JVM. Now, in cases when this is not possible, when you cannot perform such 2 build steps, we offer you ML-enabled profile guide optimizations. So it seems like it should be possible for an ML model to look at your app and understand what's doing and predict the profiles. And indeed, we have such model embedded in native image. So if you're not doing this first PGO step, out of the box, you're getting ML PGO, which will give you maybe 6-8% performance improvement over plain native image, and this is enabled by default. So this will give you additional performance if you cannot perform any manual optimizations. And regarding GC, there can be different GC strategies, but our overall recommendation, if you want specifically to target peak performance, is to use G1 GC, and this will give you, in combination with PGO, the best peak performance. And the last, and like a slightly smaller one, but I like this as well. So if you will be building your app on the machine where you're planning to actually deploy it and run it, you can pass this mark native flag, and this will use the specific hardware features of your machine, and it will make sure that it's using those features to enable even better performance. So that is the mark compatibility mode if you want to distribute your binary to different platforms or different, rather, machines on the same platform. But if you know that you will be running your app on the same machine that you're building, do a mark native, and it will specialize the binary to fit your hardware configuration. OK, and what's next for GraalVM? Recently, we had our GraalVM for JDK 22 release. So the way our release model works is that every time there is a new Java release, on the same day, there is also a new GraalVM release, so that you can use the latest of Java features and the latest of GraalVM features together in one build and even on the same day. And related to that, I want to show you 2 more demos that I have built for this release. So let's go higher up. And let's clear this. Anyone here knows LangChain4j? OK, cool. Quite a few people. So I want to show you LangChain4j demo, and specifically one that is working with GraalVM. Let me see, it's this one. So here's my Java app, where we're just taking a user input, and then we are talking to the OpenAI API to give the answer or comment or whatever to that user input. And that is basically the whole app. So let's first run it on the JVM and see what it does. So run JVM, and let's ask it something, or let's say something. Now, this is doing an API call, so I would not read too much into response times because this is just an HTTP call, so it might take slower or longer. This is not the application's fault. Okay, our model is on, so let's ask it something else. What is Java, maybe? Okay, Java is a high-level, class-based, object-oriented programming language, blah, blah, blah. Okay, fair enough. Seems accurate. But I also have it compiled to native already, so let's see what it looks like, and it's in the target folder. So this one, native Chain4j, and it's a native executable, and total size of it is 47 megabytes. So let's run that one, and let's see what we can get out of it. So let's do the same. Okay, and let's maybe ask it something more exciting. So let's maybe do, what is GraalVM? GraalVM is a universal virtual machine for running applications written in different languages, blah, 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 in a shared runtime. Well, okay, fair enough. But the point is that you can also build applications using all those latest cool libraries. And I like how it starts very fast. And it's also all those 47 megabytes. That's a complete app that I can just deploy, and it doesn't need a JVM to run. So that is pretty cool. But I want to show you one more demo that I borrowed from my colleague, Nikolai Parlog. And he has built this awesome demo where he showcases the latest Java features based on Java 22. And this is a little GitHub crawler app that if you give it a link, it will go to that GitHub link, analyze the page, and then pull all the different links from that page and categorize them and print out a cute little report for you. So this is Nikolai's demo, and I have a little fork of it. Let me just native modern Java, this one. Okay, this is my fork, and you can see it only has one commit because it didn't take much effort, to be honest. And the way I changed this app is I extended a README, whatever, and then I added native Maven plugin. That's why I'm always saying add Maven or Gradle plugin, whatever is your choice. So I added our Maven plugin, and I added enable preview because we are using latest Java features, and I'm just passing the desired name of the app. So let's run this specifically in the native image mode, and let's see how it works. So native modern Java, and let's look at what's in there. And it's the one over there. So this one is even smaller, 37 megs, because it's only using standard JDK classes. So let's run it. And it requires an input. So we need to give it as an input a GitHub page that we want to crawl. I want to find something good with a lot of links. So let's maybe do this one. And I hope I haven't abused the GitHub API too many times today, so I hope this will still work. Let's see, and I need to pass the desired crawl depths. So let's do 3, let's say. Okay, and it went and it crawled that page, and it found all those links in there, but also it pulled up a nice little page for me with the report. So let's go there. It will be localhost, again, 8080. And this is a beautiful page courtesy of Nikolai's design, where you can see all the different pages that we were able to crawl from that page and what those links are and where do they lead. And this is very cool because this is using all the latest Java features, virtual threads, records, pattern matching, HTTP server, whatever. And this is also running as a native app. So this is pretty cool, I think. And how are we doing on time? 2 minutes. Yeah, demo. And I want to show you 2 big projects that we are working on and we are also very proud of. So if you have ever built a bigger native image application, you might have noticed that for bigger apps specifically, it can take maybe a minute, maybe a couple of minutes. And not everyone has that kind of patience, and we realize that. So we are working on this new ambitious project where we want to give you a way to build your base applications. So let's say I'm building a Spring app. I can compile my JDK base. I can compile my Spring base. And then every time I'm introducing changes to the code, I would only recompile my user code, so the one that I actually wrote, and the rest stays compiled. And then we hope that we will get compilation times down to a couple of seconds, or maybe 1 second, because I'm only recompiling my application layer. And another benefit that we'll see there is when I deploy my application, and let's say I want to have 5 instances of my Spring application, I can have, again, 1 JDK base deployed, 1 Spring base deployed, and then my 5 Spring app instances can reuse those resources, and this way we can use less resources in the cloud. So that is called layered native images. It's a very ambitious project that we are very proud of, but it will take a while to happen because it's a lot of effort. But stay tuned. We are actively working on it. And another, again, ambitious project that we are working on is called GraalOS. And that's basically an operating system based on Graal, where you will be able to deploy applications built as native images instead of containers. So no containers, no container overhead, no container complexity. Just give us your native image, and we will run on a platform, and we will take care of scalability, security, etc., resources allocation for you. So those are two biggest things that we are working on. And again, to summarize the resources of GraalVM, the benefits of GraalVM, that is fast startup, low resources usage, predictable performance, improved security, small packaging, and also all the Java library compatibility in the world. With that, I want to share with you two links. One is my Twitter page, where you can ask me all kinds of questions if you want. And then the second link is a collection of resources, so demos, videos, conference talks, etc., where you can find more things about GraalVM. With that, okay, let me see if I can pronounce it. Evharisto. Thank you so much.